Hello and welcome. In this session, we're going to go over dilutions. Just a little introduction to dilutions. Dilutions are performed when a solution or a semisolid is mixed with a base to reduce a strength. If we think about a dilution, if I have a clear glass and I put, let's just say, a half an ounce of blue food coloring in it, that natural blue food coloring is very dark. It actually almost looks black. I'm going to dilute it by adding water, which is a base, to the food coloring, and the more water I add, the lighter the color gets. Now, when I use the term base, it could not only be water, but it could be cream base, ointment base, Swiffy, which is sterile water for injection, or it could also be petrolatum, which is basically an ointment base. Now, it's going to be pictured by this equation. My Q's stand for quantities. So here I have my Q's are quantities, and my C's are concentrations. Now, the ones and twos, these are subscripts. These are just noting that it's two separate solutions. We're not multiplying or dividing by ones or twos. Now, the Q1, C1 side is actually going to be my stock supply, which is what I start out with. So if I go back to my example, my Q1, C1 side, my stock supply would be my half an ounce of my blue food coloring. My Q2, C2 side, this is my product side. This is after the dilution has been performed. So it's the quantity of our stock times the concentration of our stock is equal to the quantity of our product times the concentration of our product. Placement of the numbers in the correct position is imperative. So in order for us to be able to do that, we really have to think about what a dilution is. A dilution means that we're always reducing the strength, which is reducing the concentration. So if we're given two concentrations in the problem, our C1 concentration will always be higher than our C2 because we're always going to end up with a reduced strength. Now, if we're given two quantities in the equation, my Q1 will always be smaller than my Q2. The reason for this being is because when we perform the dilution, we are adding quantity to our original quantity. So our Q2 will always be larger. So let's just take a look at some of the examples here. My first example says 6 mLs of a 96% solution is diluted to 60 mLs. What is the final concentration of the resulting solution? So here, when I perform these problems, I always pull out all of my information first and organize my thoughts before trying to plug them into the equation. In this example, I have two quantities, okay? Like we said before, we are always adding quantity to the original. So our Q1 will be my smaller quantity and my Q2 will be my larger quantity. Now let's place this percentage. If I have a percentage connected to a volume by the keyword of, they go on the same side of the equation. So for this particular problem, I am solving for C2. Now that I've pulled out all my information, I'm going to set up the numbers based on my equation. So I have 6 times 96 is equal to 60 times x. So 6 times 96 is equal to 576 is equal to 60x. I'm now going to solve for x by dividing both sides by 60. So I get x is equal to 9.6%. So my final concentration after the dilution is 9.6%. Let's take a look at an example just like that one more time. So I have 200 mLs of an 86% solution is diluted to 650. What is the final concentration of the resulting solution? So first, I'm going to go ahead and pull out all of my information before I try setting up the equation. So I have two quantities here. The low quantity will be quantity 1. The higher quantity will be quantity 2. I have a percentage connected to the 200 by that keyword of. So my 86% is going to be C1, and I have X for my C2. Next, I'm going to go ahead and set up my equation. So I have 200 times 86 is equal to 650 times X. So I have 200 times 86 is going to equal 17,200 is equal to 650X. I'm going to go ahead and solve for X by dividing both sides by 650. And I get X is equal to 26.5%. Now let's take a look at an example where instead of having two volumes, we're getting two concentrations. Now we have to keep in mind the whole point of a dilution is to reduce the strength. So again, I'm going to go ahead and pull out all of my information first. So my question reads, how much 52% solution do you need to make 500 mLs of a 35% solution? So I have two percentages here. My highest percentage will be my C1, and my lowest percentage will be my C2. I have a volume connected to my concentration by that keyword of, so they're going to go on the same side. And then I have X as my Q1. I'm going to go ahead and set up my equation. I have X times 52 is equal to 500 times 35. So I'm left with 52X is equal to 500 times 35 gives me 17,500. I'm going to divide both sides by 52 to get X by itself. And I get X is equal to 336.5 mLs. So that will be my answer. Let's take a look at an example just like this one more time. So I have how much 25% solution can be made by diluting 200 mLs of a 45% solution. So again, I'm going to go ahead and pull out all of my information. I have two concentrations here. So my high concentration will be C1. My low concentration will be C2. I have a volume connected to my high concentration by that keyword of. So in this situation, I'm looking for Q2. I'm going to go ahead and set up my equation. I have 200 times 45 is equal to X times 25. I have 200 times 45 is equal to 9,000 is equal to 25X. I'm going to go ahead and solve for X by dividing both sides by 25. And I get X is equal to 360 milliliters. I hope you found this video informational. If you have any questions, please contact an academic coach at coach@ultimatemedical.edu. Thank you for joining me.